with this chapter. After going into this unit here with 7.3, it's usually a generic break before we get to the next part with 7.4. So what I want to do is talk a little bit about the function operation stuff today. I'm going to go through these over the weekend and see if there's any tie-ups that were a little bit weird and kind of review some junk out of that. I'd like to have a quiz over 7.1, 7.3 on Tuesday. And I don't think it'll be a big deal. We're pacing out just fine. Because after 7.3, it kind of, the whole chapter changes and it goes into something a little bit completely different. So it's a very nice clean break after that. Usually we, I mean, if we kind of snuck this in a little bit quicker, we probably could have gotten a quiz today, but whatever. So this is what it's going to look like. So f of x and g of x, what this means is that f is a function of x, g is a function of x. Basically, it's y equals 2x minus 1, y equals negative x plus 1. What happens here is that you have two specific functions. Do you guys remember what denotes a function? Okay. What denotes a function is that you have, for every value of x, there exists exactly one value of y. So you have an input value of x, an output value of y. So any value for every value of x that I substitute into here, there's only going to be one value that comes out here. There's no duplicate. You've seen this in a couple of different manners. You've seen functions written out as tables. You've seen them written as ordered pairs. You've seen them as graphs, and you've seen them as equations. One way to tell whether or not something is a function is very simply, if you have a graph of it, if you have a graph of something and you do what's called the vertical line test, as you go through a graph with a vertical line, if that vertical line only touches your graph at one spot at a time, then it passes the vertical line test. Therefore, it becomes a function. We've done that with parabolas. Remember how sometimes parabolas are written as f of x equals x squared? It's because it's a function. Now, if I took this parabola and I turned it to a y equals a y squared parabola, it's no longer a function because that vertical line touches it in two spots. That's the idea of what denotes a function and what. Okay. So this thing of f of x, g of x, move this out of the way real quick. This idea of this f of x, g of x is what we're going to be doing today is basically direct substitution. We're not going to mess around a whole lot. And this is similar to what you saw on your ACT. If you took the ACT, they did some what's called composite function. They said, what is f of 3? So if they ask you what is f of 3, you have to make a decision. You have to make a decision, which equation do you put 3 into? The f or the g? Why? Because there's an f. Exactly. It's quite literally that. So what I would do is I take this f equation, not the effing equation, and f of 3 is 5. That's what function notation does. It tells you it's more or less a direct substitution thing. What you see a lot of times on the ACT is something like this. Let me move this guy up. You might see what is f of g of 2. That is a composite function. A composite function is when you start with one and put it into the other. Think of this as order of operations. Where is the innermost, guys, come on. Where is the innermost parenthesis? G. Get the g of 2, correct. So that means I start at the g equation, and what do I substitute in? 2. So what we do is, we start with the g equation, take negative 2 plus 1, that gives me negative 1. So now that is this, and you get f of negative 1, which was 2 times negative 1, what was it, plus something? Minus 1? Thank you. and then I just resubstitute it, and you get -3. So you're right, on the ACT, this is a very common style question that you see on the ACT. You'll see f of x, g of x, h of x, and they'll do some sort of composites with them. They'll add them together, they'll multiply them together, they'll divide them. They'll do a whole bunch of stuff with the function notation. It is nothing more than, quite literally, direct substitution. Right. Does that clear up what you were seeing now? It's like, oh, yeah, a lot easier than you thought. Okay. So for those of you guys that are taking, there's another ACT coming up in the first weekend of February, I think. You'll see this. So don't write all this out, but what this is that we can take the two functions, an f of x and a g of x, and we can combine them to generate a different function, just by, like I said, direct substitution. So I could take two functions and add them together, 2x plus x plus 1, and if I put them together, what do you get? Not a trick question. There it is. Take your cookie. It's the idea that you have substitution, but what's the one you're going to have to be very, very careful with? Subtraction. Subtraction is the one that always messes you guys up. 2x minus the quantity, which means what would you have to do with the negative? Huge, 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 huge. So you get, okay, things like that. Multiplying, dividing, again, it's nothing too crazy. The multiplication, you have a distributive property. If you're dividing, I don't think I need to show you how to multiply. But when you divide, you have to look at the equation to see, can you do anything? Can you do anything with that? No. Then you just leave it. Okay. It's the idea that you're just combining the two functions to create a new one, just by direct substitution, whether you're adding, subtracting, multiplying, dividing. Like I said, quite honestly, the one that will mess you up is the subtraction one, because you'll forget to distribute the negative. So which one do you think I'm going to always show you guys? Ding, 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 ding. So, does it change with fractional exponents? No. Take a second and try those two with fractional exponents. Sorry. So what is f of x plus g of x? Negative 4x to the half. It's not taking the square root of the 4, negative 4, is it? No. And what's f of x minus g of x? 8x to the half. Yes, it's easy today. You're welcome.
But wait, there's more.
It slices, it dices. Oh, I gave the answer division. Oh well, and that's not the answer.
Oh.
That's going to be a standardized rule. Great question. Do you have to get rid of the fractional exponent denominator? Yeah, that's a standardized rule. I will always ask that you guys leave your exponents with non-negative exponents and no fractions in the denominator. It's like a very basic way to learn about it. Or take a cookie away. Why didn't you save your cookie for yourself? Cookie snob. He's a snooky, snobby cookie. Dog. So putting them together again, it shouldn't be terrible. 3x, x to the fourth gives you 3x to the 5/4. When you divide this out, you get 3x, excuse me, to the, what's that, 3/4? And you go on very well. Now, did anybody try just to rationalize that? Watch what happens if you rationalize that. If you rationalize this, you multiply top and bottom by a 3/4. And if you do that, you get a full x in the bottom. And you get, was that 7/4 x up top? Isn't that more than a whole up top? And that's why I can simplify. Does that make sense? It's a very common thing that people, I just want to rationalize. But then sometimes if you've got a whole up top and a fraction, you're going to wind up too much. Oh, okay, yeah. Yeah, you just went down the extra step there. No biggie, okay? All right, try it with composites. Composites mean the easiest way to do this without numbers, the easiest, when you have f of x is 3x to the -1 and g of x is 2x minus 1. If I want to find the composite of f of g of x, the easiest way that I've ever seen to do this is to quite literally write down what the innermost function is first. So if I'm doing f of g of x, what's the innermost function? G of x. So what I do is I write down 2x minus 1. Now, that value is the x value of the f function. So what I do then is I surround that with the f. Because what you're doing is you're taking that function of g and you're substituting it into the function of f. So you start by writing out what the innermost is and surround it with everything else. What you're doing here is you're taking this value, whatever that is, and you're substituting it into the x here. When you're doing composite stuff, because if we did this with a number, if we did f of g of 1, if I did f of g of 1, I'd figure out what g of 1 was first, and I get 2 minus 1, which was 1. Then I'd take this value of 1, and I'd throw it to here. It's the same idea, but it's non-numerical. There's no number. You're just taking the actual function of it. This is actually, we'll get to the fancy part of how you can create composite functions out of word problems. We'll do that on Monday. It's not worth it to do it on a Friday because you're not going to do it anyway. What? I've learned not to fight that. No? What is g of, what do you do for g? Oh, for this one, what do you have to do to simplify it? Yep, so this one is just quite literally that. Second one, you have g of f of x, which means you start by writing down the f equation and surround it with the g. The f equation is 3x negative 1. To that, I surround it with the g equation. Bless you. Bless you. I am taking that f of x equation, that function, and it becomes the new x of the g equation. Yes, ma'am? No, because what's being raised to the negative 1? Just the x. Okay? So in this case here, because this was the value of x, this value of x is this whole thing. Easy way to think of this. If I have f of x equals, we'll use the same idea, 3x is negative 1, and g of x is potato. If I say what is f of g of x, what do I do with the potato? The easy way to think of this is stupid to go this route, but what you're thinking of, it means take whatever this is and write it down. To that, this is now playing the role of the x of the f equation. So then I surround it with everything else. Correct. If this were, you're not dumb. You're not dumb. Don't say that. Don't ever say that. Seriously, don't ever say that. You see where we're going though? It's weird to wrap your head around it. Going, what? It is direct substitution. Ish.
That would be the answer.
Okay. Now, if it is, here's the weird one. Let me move this up here. What is going to be when I have f of x? When I have f of x, it means write down the f equation and then surround it with the f equation. So it's 3 and now that's playing the role of x. Whose phone keeps going? It's not. Okay. So in order to solve this one out, watch what happens. Power to power, in this case, I would just distribute the negative exponent, correct? So I get 3 times 3 to the negative 1, x to the first. What's your answer? X. Your answer here is x. Because this becomes 3 Did Lockhouse put something in here to make me annoyed? What? No, when you do it, it's not funny. domain. You guys remember what domain stood for? Domain. What happens here when we're talking about domain? Your domain is always going to be your possible values of x. Now, a lot of times you're not going to have to worry about domain restriction because if you're not dividing by a value of x, you generally won't have a domain restriction for that. So if you have anything that is like 3x squared, or 3x minus 2, or negative x plus 4, you're not going to have to worry about any of that because it is all numerator stuff. There isn't a value of x that will work, so we would basically say all these numbers. When you have like a number of 8, if I show you that particularly little goes over the loophole of it, you look at one like number 8 where it has f of x divided by 3 of x. If you have f of x divided by 3 of x, it becomes a rational expression. And we've dealt with rationals already. We did that right at the very tail end of last semester. So if I have 4x, I know I heard it. If I have 4x over x minus 1, what's the restriction within the domain? What can't x be? 1. So for this one here, my domain values J lemma's face x such that x can't equal 1. J lemma's face. Yes. That's what that means for domain. I don't remember if the ACT asked for the domain values on some of those. It did? Did you see the problem on there? Did it have it written out as triangles by chance? On the ACT? There's a problem in the ACT. Oh no, this bar means such that. Domain, it's just say x. So there's an ACT question that's been around. This has been an ACT question that's shown up pretty regularly, some form of this. This is a different way of writing out function notation. Now, what this is doing, if you think of this in terms of now knowing what function notation looks like. Guys, please. Now that you know kind of the idea of what function notation looks like as, f of x equals x squared minus x for all integers, how would you say the next one? So a triangle of x equals x squared minus x would be triangle of 3 is what? So, right. So this, what's that? So this would be 3 squared minus 3, which is 6. Then what do I do with that 6? 6 squared minus 6, and you get. This is the same idea as saying f of x, and this is f of x. It's an ACT question, guys. It is on there. It's on the study guide of ACT for function notation. It's right there. Okay. I have, if any of you guys ever want, I do have some ACT extra practice things and whatnot. I have the little study guide. If you guys ever wanted to borrow it when it gets closer or anything, just let me know and I'll let you guys borrow it. But I have some stuff like that. Yeah, this is like you were saying, the ACT ones, they probably look, if you've taken it, they probably look like that. Now you know what you're doing, so you should do better. Okay? Pretty much it.
You ran around saying that you get it. You get it. Idiots. I had to idiots. Here's the average.